Good morning students. Here we are with a new video which is the type of X-rays. But before starting this video, let's just have a quick recap for the production of X-rays. So when we heat the filament which is present on the cathode side, there will be the emission of electrons, and after that we accelerate these emitted electrons towards the anode, and these electrons are going to be suddenly deaccelerated at anode, which leads to the production of 99.9% of heat plus 0.1% of X-rays. But here we have two types of X-rays. We are going to get actually two types of X-rays. So what are they? Let's discuss that. First one is the Bremsstrahlung radiation, which is also known as continuous spectrum. Why? We'll see that. But when an electron, here what happened, that when an electron which is just coming from cathode side and going to interact at anode, so that when electron passes near the nucleus, that electron experiences a sudden electrostatic attraction. Why? Because electron is negative charge, and inside the nucleus of an atom we have a positive charge plus neutron. So that's why there is an electrostatic force of attraction. Due to this, the path of the electron gets bent and there will be a small deacceleration of the moving electron, but that bends towards the nucleus. And according to the law of electromagnetic theory, any accelerating or deaccelerating charge emit radiation. So this electron going to emit the X-ray photon. But how much the energy of that X-ray photon? The energy will equals to be the loss of kinetic energy of electron. Since the electron can pass at different distance from the nucleus, if it is far, small energy loss; if it is near, large energy loss; and if it is direct hit, there will be maximum energy loss. Due to this, as a result of this, photon energy varies continuously, and that's why this is the reason that why we call it as continuous spectrum. I hope the concept is clear for the Bremsstrahlung. Now let's discuss the continuous or the characteristic spectrum. Second is characteristic radiation. So the physics behind this is that when an incident electron transfer energy to the inner shell of an electron, mark this word, here the electron transfer its energy to the inner shell of the electron, means the shell which is just near to the nucleus, that is K shell, or it can be L shell. If the energy of the incident electron is more than the binding energy of the electron which is present on the K shell or the L shell, then electron is going to be ejected out from that shell with the help of photoelectric type of interaction, and as a result of this, atom become unstable and vacancy gets created. So at that time, higher energy electrons falls to the lower energy states and emit the photon or the X-rays, which is equals to the energy difference between the two shell, means from which the electron is coming to which the electron is coming. That energy difference will reflect in the form of an X-ray, which is known as the characteristic X-ray. Now the question is that why we are calling this as characteristic spectrum or the line spectrum. The reason for that is that only specific photon energies are possible, because that energy will vary from material to material or the shell to shell. That's why we are calling this as line spectrum. I hope the concept is clear. Let's have a notes. Thank you.